Hi guys, welcome back. In today's video, we're going to be continuing to work with binary trees. In the last one, we had an introduction. In this one, we're going to start talking about how we can loop through the binary trees to print out all of the nodes within the tree. And so over here, I just have an example of a basic binary tree where we have 1, 2, 3, 4, 5, 6, 7. So this is what we would call a complete tree, where the 1, 2, and 3 they have left and right nodes, and at the very bottom are just the leaves, and it's a complete tree because all the leaves are filled in. And so we have this basic binary tree. This is kind of the code I used to set it up. I just set the left and right nodes based on the starting from the root and moving down. But what I want to do is we want to loop through and print out every single node in this tree. And there's a couple different ways we can do that, but one of the methods we want to do is we want to loop through the left side of the binary tree first. So we want to print out 4 to 5, and then print out the 1, and then loop through the right side of the binary tree and uh, print out the right side of the binary tree. And so one way we can do that is a pattern called Inorder Traversal. So what that means is we just look at the left side of the tree and we go to the leftmost, in other words, as left as we can go in the tree. So in this case, the furthest to the left we can go is the 4. So we want to traverse through the tree so that we get to the 4. We print out the the root or the parent of that left node, and then we go to the right node. So we keep going down the left side, and once we get to the very left, we want to print the parent of that left node, go to the right node, and then after we print out the left, the root, and the right node, we want to go to the parent of our root node that we just printed out. Not necessarily root node, but the parent of the parent node that we just printed out. So the parent of the 4 and 5 is the 2, and so you want to go to the parent of the 2, which in this case is the root, which is the 1. And then once we do that, we want to go to the right side, and once again, when we're on the right side, we want to go to uh, the leftmost side on the right side of the binary tree, and in this case, that would be the 6. So we want to print out the 6, then print out the 3, and then print out the 7. So what we're basically doing all throughout is we're starting from the very top of the tree. We're going to the left side. We're going within the left side. We're going as far to the left as we possibly can. We print out the left, the parent, the right node, and then we go back up to the parent of the parent node we just printed. And we keep doing that until we get to the root node at the very top. And then once we do that, we do the exact same thing, except we're just doing it on the right side of the binary tree. And so hopefully, I think it'll make a little more sense once we start typing in or coding up the algorithm. If you guys want, pause the video and try it on your own. But if you guys need help, come back and we'll work through it together. So what I have here is I have two functions. One is going to be the in-order traversal that we're going to call, and the second function here is just a helper function that we're going to use. And so what we're going to do is I'm going to remove this pass, and I'm going to say I'm going to initialize a string, because what we're going to do, we're just going to add to the string to print out all the data elements of each node in the tree. And what I'm going to call return self dot in order helper string and the self dot root. So all this is doing is we're just going to be calling the in order helper, and with this in order helper, we are going to be adding to the string as necessary, and we're starting off at the self dot root. And what we're going to do with the in order helper is this is where we're going to do the actual traversal. And so we're going to use recursion. What that means is we're going to be calling the function on itself, and once we get to a base case, we return. And so what we want to do in this case is we're going to want to first check if there's a node at that position. And so if there is a node at that position, we are going to do a couple different things, and I'm going to return the string. And so what we want to do first, we want to check check the left node of our current node. So if we're starting at the self.root, we want to check to see if we want to run our in-order helper on our left node, or the left element of our root node, because we want to go to the leftmost as possible. So we'll call self.inOrder helper. This is where we call it on in of itself. We're going to pass the string, and then we're going to say node.left. So what this is going to do is if there is a node.left of our current node, which in this case is the 2, it's going to run our in-order helper. It's going to run it again, except it's going to run it on the 2. And then what's going to happen is once we get to the 2, it's going to run the whole thing again. So it's going to check, is there a node? If there is, we're going to check if there's a node.left again. So we're on the 2. Since there is a node.left, we're going to run it on the 4. So now we're running the whole thing on the 4 again. We're checking if there's a node. And so we pass that. This returns true because there is a node with at this position. We're checking if there's a node.left. There isn't. And so what we want to do now is we want to print out the data element in the string. So what we're going to say is string plus equals node.data plus dash at the end. So what this is going to do, we got to the very left of this node. And so we're going to print out the data element, which is a 4, add a dash after it. And now we want to check if there's a right node for this node, because we want to print out the left and right nodes. So I'll copy this, except we're going to be calling this on the right node. And so what this is going to do is if we start at the very top again, we start off at the root, which is the 1. We run this string is equal to self.inOrder help node.left with the node.left. That moves us over to the 2 node. We run the whole function again, and we check if there's a node. There is, so we run this line again. We get to the 4, and so we run the whole thing again. We check if there's a node.left. There isn't, so we run this line of code. We add a 4 and then a dash to our string. Then we run this line of code and check if there's a node.right. There is not, and so then we return the string. So remember, at this point, our string is a 4 minus. And now what this does is we loop back up to our parent node, or the parent of the current node that we were on, which is a 4. And now remember, when we were at the parent node before, we ran this line of code, and that's why we moved from the 2 to the 4. So once we've run this line of code, what we want to do now is we're going to be running this line of code here, the second line, where we're adding the node.data. And so what this is going to do, this is going to add the data element of the 2. So now we have a 2 minus. And then we're going to be running the right node we're going to be checking if there's a right node in our node.right. Since there is, we're going to go here and we're going to loop through everything again. So what that's going to do, we're going to check if there's a node. There is. We're checking if there's a node.left. There is not. We're going to add the data element of that node, which is going to yield or add a 5 dash. We're checking if there's a node.right. There's not a node.right on this 5 element. And so once we've done that, we've run these 3 lines of codes, and then we're going to return the string. And so now that we've returned the string after looking at this 5, we're going to go up, and we're now at this 2 node, right? Because that's the parent node, and on this parent node, we just ran this line of code. So once we've ran this line of code, we've checked the left side, printed out the parent, we've checked the right side, and now we're just returning the string that we created after we run through all the lines of code for this 2 node. And so what happens now is that when we were on the root node, we ran this 1 line of code, right? We ran it, and that's how we went from the 1 to the 2. So now what happens is we move back up to our root node, and now we're going to be running the second line of code over here. And so once we do that, we print out the data element for our root node, and now we're doing the whole thing again on the right side of our root node, which would be the right side of the whole binary tree. And so what that does is we go to our node.right. We run this loop that returns true. We're checking if there's a node.left. There is, so we go to the 6th. We run the whole thing again. True. Check there's a node.left. There isn't. Check add our node.data. Check if there's a node.right. There isn't. So then we go back up to our parent node. Now since in our parent node, which was a 3, we ran this line of code, we're now running this line of code. So we get the 3 minus, and we get the 3 minus, and we added this data element. Now we're running this third line of code where we get the we look at the 7. We check return true. This will return. Does not have a node.left. We print out the node.data. Add a 7 minus. Check if there's a node.right. There isn't. And then we loop back up to our root node, and that's the end of our binary tree traversal, because we've looped through every single node and we've looked at every single node there is to see in our tree. And so if I save that, this is, and I clear out of this, this is a direct representation of this node right here, because we have our root node. The left is 2, the right is 3, the left of the left is 4, 5, and so on. You can compare if you'd like to. And so once we ran that, we just check, and we just need to call our bt.Inorder Traversal, because once we get back up to after traversing the right side of our binary tree, we go back up, and after we've ran this line of code on our root node, we're just going to return the string, which is going to have everything that we everything that we added to the string. We return the string, and that is what will be returned over here. And so if we do that, we should get this little string right here. So if I run that, Python 3 bt.py, we get 4251637. So this is exactly what we got. And so this shows that we traversed everything, the whole node, the whole tree properly, and we moved from our left to our parent to our right node for each of the respective nodes we were on. And we check to make sure that if there is a node.left or if there is not a node.right, and we check those to make sure that we can do those. And so that is the end of our in-order traversal. There's other ways to do this, and we'll look at those in the future. But hopefully this helps you guys, and see you guys in the next one. All right, later.